Hey there! So if you're gearing up for your WAEC, JAMB, or NECO chemistry exams, you have absolutely come to the right place. This whole explainer is designed to help you completely master one of the most fundamental topics, matter and separation techniques. Okay, let's jump right in. Here's the game plan for today. We're going to start with the absolute basics. Then we'll move into the practical techniques. We'll tackle some real-deal exam questions and then wrap up with some final tips to make sure you walk into that exam feeling confident. First things first, we've got to build a solid foundation, right? So let's get crystal clear on what matter actually is and why it's such a make or break topic on your exams. And it really is that simple. But don't let that fool you. This one little definition is the starting block for everything else in chemistry. Every reaction, every concept, it all comes back to this simple idea. Now, this classification is so important. Why? Because knowing if something is a pure substance or a mixture is the first step in figuring out how to deal with it. This chart right here tells you which separation methods are even possible. Next up, let's get into how matter actually behaves. We're going to look at its different states and the incredible theory that explains all the magic happening behind the scenes. Honestly, this theory is a total game changer. It's the why behind so many things we just take for granted. You know when you can smell food cooking from another room? That's the kinetic theory in action. It's all about those tiny particles buzzing around. And this table just lays it all out so clearly. Look at the connection between how the particles are arranged and their energy. As you pump in more energy, usually heat, those particles start to move more and more, breaking free from a rigid solid to a flowing liquid and finally to a gas spreading all over the place. And these are the transitions you have to know, no question. The key thing to remember is these are physical changes, not chemical ones. When ice melts, it's still H2O. Its molecules just started moving differently. And then you have that special case sublimation, where a solid just says nope to the liquid phase and goes straight to being a gas. Alright, we've got the theory down. Now let's get practical. It's time to open up the chemist toolkit and look at all the clever ways we can separate the mixtures we were just talking about. Think of each of these as a specialized tool. You wouldn't use a wrench to hammer a nail, right? It's the same thing here. Each technique takes advantage of a different physical property, like particle size or boiling point or solubility. Your job is to know which tool to grab for which job. Okay, pay attention here because this is a super common point of confusion. Let's take salt water. You could use either method, but it all depends on what you want to keep. If you just want the salt, evaporate the water and let it disappear. But if you want pure, clean drinking water, you have to use distillation to capture that water vapor and turn it back into a liquid. Okay, theory is done. It's time to hit the proving ground with some real past questions. Now here's how we're going to do this. I'll put the full question right up on the screen. I want you to take a second, read it, and try to solve it yourself before I walk you through it. Ready? Alright, here's our first one. It's a classic from a past exam. Black ink looks like it's just one thing. But is it really? Which of these methods would prove it's a mixture? Take a good look. Have you got an answer locked in? So, how did you do? Let's break this down. The magic word in the analysis is dissolved. You can't filter something that's dissolved, right? That's why chromatography is the perfect tool here. As the solvent creeps up the paper, it pulls the different dyes along at different speeds, revealing all the hidden colors. So the answer is B. And that brings us to a huge exam tip. Before you pick a method, always ask yourself, is the thing I'm trying to separate dissolved or is it an undissolved solid? Just asking that one question will help you dodge so many common exam traps. Okay, next up, a JAMB question. This one isn't about choosing a technique, it's about identifying a process just from the description. So, you hit a solid, it vanishes, and then it reappears as a solid somewhere else in the tube. What in the world is that called? That what you're reading there is the textbook definition of sublimation. The solid ammonium chloride turns straight into a gas, and then that gas hit a cooler spot and turned right back into a solid, completely skipping the liquid phase. So our answer has to be B, sublimation. And this is a fantastic tip. They love to try and trick you with the word decomposition. But decomposition is a chemical change where the substance actually breaks apart into new things. Here, the ammonium chloride was still ammonium chloride at the end. It just went through a physical costume change. All right, last practice question. This one is from NECO, and it connects what we're learning to a massive real-world industry. How do we get things like gasoline and kerosene out of that thick black crude oil? This is where precision is everything. Crude oil isn't just a simple mix of two things. It's a complex soup of hundreds of different liquids, and a lot of them have very, very similar boiling points. A simple distillation just can't handle that. You need the much more powerful, high-precision version, fractional distillation. So, the answer is E. Fantastic work. You've made it through the training ground. Let's do a quick final briefing to lock in the absolute most important points you need to remember on exam day. Think of these 4 points as the absolute cornerstones of this topic. If you truly understand these 4 ideas, you can think your way through pretty much any problem they decide to throw at you. And here's how you turn that knowledge into points. You have to be strategic. Eliminate the crazy answers first. Practice drawing your diagrams until you can do them in your sleep. And please, practice with past questions. It's the best way to see the patterns. Just think about that for a second. The journey water takes to get to your tap involves so many of these principles. Things like filtration and sedimentation. This science isn't just in a textbook. It is literally all around you. Now you know it. You're ready. Go ace those exams. For more practice questions and solutions, visit examkp.com.